Okay, so this presentation is about a fun little project I did in February and also over the summer. Probably spent too much time on this. So this is me up there. My name is Alex Hiatt. I'm a freshman CS major, and I do a lot of tinkering in my spare time, maybe too much. I didn't take any CS classes in high school. I just did a lot of Googling. I've been self-taught till now, but I get some help with my the nastier C bugs from my stepdad because he knows more about it than I do. And I got started by modding Unity games with DNSpy, and I did C# code. And then I switched to C++ so I could use write process memory. Made some hex editor stuff. That's how I got into lower level languages. And at this point, I'm usually using C, mostly out of habit. So process injection, you are forcing another program on your computer to run code against its will. It's not actively trying to stop you usually, but it's not intending to run your code. And it gives you complete control over the program generally, and you can use you can overwrite memory, and you can overwrite code in the process's memory to redirect the functions. So when it tries to call one function, it'll be redirected to your code instead. You can use that to do. It's kind of like a man in the middle style attack, where you can you can manipulate all the inputs and outputs of the function. You can totally re-implement the function however you want. And I use that a lot to, whenever it tries to open a file, I'll redirect it to a different file, which is really useful for adding mod support. So the basic steps for it is that you copy a small piece of code into another process. And this is often assembly. Not sure why. You can write it in C, it's fine. And usually this is just like a foothold to get a real payload in, usually a DLL for DLL injection, but it could be something else as well. And the payload is just the main program that we actually want to be running in the target process. And then we somehow force the target process to execute our code. You can do this with create remote thread, which is like the super simple way. You can use thread hijacking. You can hijack the exception handling system, which is kind of wacky. But I'm just going to be using create remote thread because it's nice and simple and it's pretty self-explanatory. So 90% of the time, this is malicious, somewhere that viruses are going to use to steal information. But it's kind of the holy grail for game modding because you can do literally anything to the game. So you can completely rewrite any function of the game with any code you want. So if you're willing to put enough time in, you can do whatever you want. So one useful mod, like I said, is to redirect when a game tries to open a file. You can redirect it to a mod folder and have it load from there instead. So instead of having to keep backups of files or replace the original data, you can just delete it from the mod folder and everything goes back to normal, which is awesome. And it's non-destructive, as in it doesn't overwrite the original data that's there. And it's easy to undo your mods. So Smash Ultimate only has this one 16 gigabyte file. If you look in the files it has, that's the only one. If you want to install any mod, you have to overwrite this file. Install two mods, they both have to patch it. It's a complete nightmare. So the mod loader for Smash Ultimate uses form process injection to run as part of the game process and overwrite those file loads from accessing this file to access something on the SD card, which is a great example of how you can use process injection for modding. And someone also made a hide-and-seek multiplayer mod for Mario Odyssey with this. And they basically pretend to be Nintendo DLL to get loaded. And I guess they're using function hooking to load files from the mod folder. This is the game that I'm modding. It's called Phantom Dust. It has the mechanics of a card game, like deck building in a mana system, but each card is represented by like an actual 3D attack that you can dodge or you can block. So instead of in a card game, you just play a card like a fireball and it deal 2 damage. In this one, you could duck behind a pillar, and then the pillar breaks, and then the bridge that it's supporting falls over, and then people take 3 damage from multiplying. So it just adds like more dynamic gameplay to it by being able to dodge things. And if you want more info, you can look up Nick Robinson, Fan of Dust. He has a great video about it. That's where I stole all these screenshots from. And it's a first-party Microsoft game from 2004. This is by their Japan division. And it was for the original Xbox, developed around the same time as the console itself. And they lost most of the source code, but they were eventually able to port it to give the app on Windows 10 and Xbox. And it hasn't been updated since 2017 when they ported it, which is, I guess they just don't have the source code anymore. Same developer as Panzer Dragoon. And they have as the same acronym PD. Don't know what's up with that. Why am I modding this game? It's just kind of fun. I was bored. And there's like 10 other people working on it at most, so I can just kind of do whatever I want. There's no like other modeler I have to deal with. It's just I can just kind of do whatever. And there's only one platform, which is Windows. I have to support, which makes my code nicer. And so I wrote a mod loader that will load DLLs into the game automatically, so you don't have to deal with a DLL injector and writing your own DLL injection code. You can just drop a DLL in the folder and it just automatically loads your code, which is great. And I'm also using function hooks to force the game to support mod loading. This is also really nice because since it's a UWP app, the file system is locked on it. You don't have write access to the files of the app. So you still have write access to its roaming state folder. So you can drop your mod files there. So you can do that without side loading the game, and you're able to overwrite what data is loaded. I forgot to make this appear one at a time. It's written in C, again, out of habit. Could use something else, I guess. So I have an open source DLL, which implements the mod loading, loads the DLL part. And then I have a closed source part, which is the injector. I'll go into why that's closed source later. It was really annoying. And that loads the open source part and then sticks around to stop you from joining normal games, because this is an online game with peer-to-peer matchmaking. So you can just tell the other player that you dealt 10,000 damage and they'll just believe you and die instantly, which is great. And I don't really want to make that problem worse by making it super easy to just drop in a cheat DLL, and I don't want to make that easier. Make the problem worse. So I'm resetting the version number to 0 every millisecond, so that you won't appear in any server lists with other people, and that stops you from being able to cheat in normal matches. And obviously I can't put this in the open source half, because then you can just comment it out and it defeats the point. If I put in its own DLL, you could just like delete it or patch it and make it do nothing, which would also defeat the point. And I'm using a function hooking library for this, because I'm also hooking the function that checks the version number and then resetting it again, just in case someone is trying to reset it back to the normal one faster. And injecting that whole library would be impractical, and I don't really know how. It would be a huge pain. So I was thinking, what if you could just inject the whole injector into the target without having to have a separate DLL file that does this? So that's where PE injection comes in. And if you're not aware, it stands for Portable Executable, which is just an exe file, basically. And this lets you inject code without having a whole separate DLL. You can do a whole executable instead of just one function at a time. Basically, you have to make a copy of yourself, or whatever PE you're injecting. You can also use this to like hide one executable inside another, which might help you fly under radar antivirus, which could be nice. And then you have to update all the absolute addresses in the executable. I'll go over that in a bit. And that's called relocation. And then you have to copy the image into the other process, and then force it to run your code with any of the other methods I mentioned earlier. I'm just going to use create no thread. So you just need permissions from Windows to write to its memory, allocate the memory, create a thread, That part's pretty simple. Use get module handle to get the address of ourselves and allocate memory for it. You can see I'm using get module handle here, and these structures I'm using, you can find them in one of the Windows headers. And then I use malloc to allocate in my local process, and virtual alloc ex to allocate it with execution permission in the other process. And I've removed the error checking. Please error check your allocations. I just didn't have space for it, so please don't do this. So the reason that you need to relocate stuff is that static data like function addresses, or if you have a global variable that's never going to move or change, instead of having to store the offset that it's located in the executable and then adding the base address every single time, it's a wasteful additions. They just do the addition once at compile time, and then assuming it's this address, we'll do that addition at compile time and then just save that absolute address in the executable. But if it gets loaded somewhere else, all of that assumption is totally wrong, and you need to change the base address that it was at to the new location. Since the Windows loader needs to do this sometimes, it's built right into the executable format, and the compiler generates this for you in the executable. It's called a relocation table. And here's a rough diagram of what that would look like in a chess program. So this is that 8x8 grid that would be your chessboard, assuming 1 byte per square. So normally at the top there in red would be where the executable would be normally loaded, and then in green is where we're trying to move to. As an example, it's just 8 bytes ahead, so that I don't have to deal with hexadecimal in this presentation. So if we assume the offset of this board is at hex 100, it's going to be at the space plus 100 and at 140. If you relocate the executable and it gets loaded at the base address plus 8 instead, your address of the board here is still going to say that it's located at 100. And if you try to read the first row where you're expecting it to be, it's going to end up being garbage data, or it's going to crash. Probably going to crash in the real world. So that's a problem. So you need to calculate the difference between this and this. It's just subtraction. Use the relocation table to find this address, and then you add that difference here, so that now it's pointing to the correct address, and you're not trying to like load off the beginning here and it's all invalid, or trying to access the last row and get the 7th instead. It's a whole mess. You don't want to not relocate your addresses. It'll probably crash. So what that looks like in code, we've just got this target image, which is the address we got from virtual alloc, and image base, which is the one we got from malloc. And it's just subtraction. This difference is called the relocation bias, and the one that we're already loaded at is called the preferred address. So you just add this relocation bias to each address in your program. And I'm not gonna, I had code up here for how to actually loop through the relocation table, but it was just kind of annoying and it was really confusing, so I just removed that. You can find all the details on NSDN if you really need it. They have all the information you need up there. So I just removed that part. Then you need to, like I said, you need to copy the relocated image into the target and create a new thread. And that forces, that Windows forces that other process, because we asked for permission at the start, to start running that function in non-executable. And that's just a write process memory. And like I said, I'm just using create no thread, no fancy stuff here. And you might notice I'm adding the relocation bias to the entry point. And that's because this is a function pointer, and that's one of those static addresses that you need to relocate in an executable after you copy it. So I'm having to relocate it right before passing it into create no thread to avoid it crashing. Some pitfalls with this. I wrote and tested this on WGCC. but the function hooks from the injected executable seem to crash in SVC. I don't really know what's going on. It's probably some linker settings I need to tinker with. I don't know. So this may or may not work for you. It's kind of funky. They weren't really designed to do this, I guess. And it does not work on packed executables. So there's a tool called UPX, which it's like 7-zipping your program and attaching 7-zip to the start of it, and then it decompresses itself and runs the decompressed image. And with this method, it's going to try to run the compressed data as if it were uncompressed data, and it'll crash. So I haven't figured that out yet. It doesn't work on packed executables right now. Some extra details about the actual project, my mod loader that I wrote. I'm using this cool library called RITSEC to load from 7-zip RAR files. It handles all the decompression for me, which is really nice. I'm glad I didn't have to write any of that. And the DLLs can actually be inside of zip files. So I'm using memory module to load it from buffer. I just load the DLL into memory, and then I use memory module to load it into the process from there. And memory module also handles all of the DLL imports of everything you load. So you can also you can have DLLs depend on other DLLs that are inside completely different archives. So you can have two DLLs and two separate zip files depend on each other, and they'll link against each other as if they're totally normal DLLs on the file system, which is pretty nice. I use lconsole to create a console window, and I have to redirect the output, so I get like console output for debugging. I'm using this minhook library, like I mentioned earlier, for my function hooking. This is mostly so I don't have to use Microsoft detours, because that'll get you flagged pretty hard. Using Microsoft detours, it's kind of obvious to antiviruses. And I'm using the function I'm hooking is create file. There it goes. I'm using create file 2 to implement the mod loading to that's the function I'm hooking for it. So first it searches for zip archives, and then in the mod folder itself, and then as a last resort, it checks the original game files for what you're looking for. So that makes sure you can you're always going to be loading the mod files first before it resorts to the original. And this is just a little diagram I made to show the nice virtual file system thing. So I can have stuff add to a directory, and then I can just use a normal like C file stream style API to access these files and just read from them. But it'll handle all the decompression to get it from this RAR file or the zip file or the 7-zip file automatically, which is amazing. And it also means that when you install a mod, you can just copy paste it into the mod folder instead of having to extract like 5 zip files, decide which one overwrites whichever one. It's a huge pain. This solves all of that. You just copy the files in and you're done. So my conclusion, you can do a surprising amount with very little low-level code. The whole open source part is like 450 lines of code on my side. If I include all my dependencies and everything that's being compiled, it's like 15,000, but I don't have to write any of that. So it's a very small amount of low-level code, and it lets you load DLLs. It's like very extendable. You can load new custom files into the game, which is super helpful for modding. That's saved me from having to pull out my like 5 gig backup file of the entire game several times. So it's been really convenient, and it wasn't that much work to write. The injector half is about 200 lines of code, 1,800 if you include the dependencies it has, which I wouldn't. I'm just trying to give you an idea of like how much code complexity there is in the binary. And this is with the 32-bit code removed because I'm not compiling that. And most of that is just decompression code because that's just really complicated, I guess. This is the GitHub link you can find the open source half of it at, just because I wanted to like be able to put it on my portfolio, I guess. And I think that compiles with MSPC at the moment. And I was able to write half of FreeCam. 3 projection sucks, so it's not going well, but I'm working on it. The FreeCam mostly works, and I have another mod that will patch the text files in the game because it's one of those structures where there's one file that has all the text in the whole game and all of the cards in the whole game. So this will let you put in individual files and patch them into memory, which helps a lot because then you don't have to. It's that same situation with Smash where there's one file that controls everything, and it lets you make those all separate files. These are my sources, I guess. The relocation structures, like I said, they're in Windows.h. If you need those, you're going to need this structure. If you want to actually do the relocation, you can find that on MSDN, the actual spec for it. And if you just Google this name, you'll find like a million different copies of the same bit field structure online. It's pretty easy to find. And that's it. I don't remember putting that on the end. I think that's the default. Huh?
Is there any questions?
Oh, I don't think there's any questions.
So you would say you did a lot of function hooking, right?
Yeah, lots of function hooking. Yeah.
What would you call something that hooks around your neck and carries some certain keys or so?
Function lanyard. Is this on?
Oh, no.
Lanyard.